Hello guys, welcome to this example of joint density functions. Let's begin. Suppose that you own a gas station or you work at a gas station and you have a tank that is filled once a week, let's say every Monday, and then that gas is sold to individual customers. So let's define our first random variable x, and let x denote the proportion of the capacity of the tank that is available for selling after the tank is stuck. Because of limited supplies, x is a random variable. Let y denote the proportion of the tank that is sold during the week. So one thing that you may notice right away is that x must be always greater or equal than y. Why is that? Because if we have X amount of gas in our tank, then we cannot sell more than what we have. So now let's say that the joint function for x and y is given by this density function. Again, you may notice right away that the names of the variables are not the same. Here I wrote x and y, but the function has y1 and y2. In a couple of minutes you will see why I switched the names to x and y, but it's the same thing. Imagine that instead of y1 we have x, instead of y2 we have y. So this function is going to take the first coordinate and multiply it times 3. And that's going to be the value for the density function for any pair of values y1 and y2 or x and y, and it's going to be 0 elsewhere. So this is going to be a two-part video. In this first part we're going to graph the density function, and in the second part we're going to compute the probability that less than 1/2 of the tank will be stuck, and at the same time intersection more than 1/4 of the tank will be sold. So since this is a function of two variables, x and y, this graph is not going to be a graph in the xy plane, but this is going to be a graph in a 3D space. So before jumping into this 3D space, let's try to figure out how to begin. So this is an xy plane. This is going to be the base of our surface. So the x-axis represents the amount of gas that we have. Since we're working with proportions, we can only take values between 0 and 1. And the y-axis represents the amount of gas that we're going to sell. Since the amount we're going to sell cannot be greater than the amount of gas that we have in our tank, this triangle, this area, represents all the pairs x and y that can be input into our density function. So let's say that we have here in our x-axis, we have filled our tank to its maximum capacity, 100%. So if I have my tank at 100% of capacity, then I can sell 100% of that gasoline. But I may also sell 90% or 80 or 50 or 0, right? I can go all the week without selling. But I can also have all of these combinations. Why this upper part is not selected? Let's take this point over here, 0.2, 0.7. If I have 20% of my tank, I cannot sell 70%, right? Nor 60, nor 50. So the most I can sell if I have 20% of my gas tank is 20%. So this line, y equals x, represents one of the boundaries, one of the limits of how much gas I can sell. This line represents another limit, and this the next limit, the other limit. So Now let's take this triangle and try to translate it into a 3D model. So now here we have the three axes. The red line is the x-axis, the green line is the y-axis, and the blue line the z-axis. So the blue line is going to be the value of our density function after we input the coordinates. So since we're working with proportions, let's make a big zoom so we can work in x from 0 to 1 and y from 0 to 1. So this triangle is translated into this 3D space like this. Let me draw a kind of the same triangle. So we begin at 0, 0. Now we go all the way until 1. Now we should go until 1, 1. I may have to adjust this. And now we go all the way to 0, 0. So as you can see here, my point C is not 1, 1. So let me arrange it. This should be 1. This coordinate should be also 1. And that's it. So this triangle, all the feasible pairs of x and y is the same as this triangle. So now how can we begin to give it volume? How can this thing get volume? Well, we just need to use our function, our density function. So for any pair of coordinates x and y, our function is going to take just the first coordinate and multiply it times 3. So let's go back to our 3D model. So let's take the point 0, 0, 0. This point in the xy plane will have coordinate in z equal to 0, right? Because the x coordinate is 0, so 0 times 3 is 0. Now let's work with this point B. The x coordinate of this point is 1. That means that our function is going to take this 1 and multiply it times 3. So we will have a point, let's call it point V. I'm working over here so you can see what I'm doing. That point is going to be 1, 0, 3. But it's not here, it's not displayed. Why? Because of the zoom on the z-axis. So if we move a little bit outward, we can see our point D over here. Let me move a little bit. So where is my point D? I lost it. Let me write it again. Point D is going to be 1, it's going to be 1, 0, 3. There's our point D. So now our point C will have the same fate. Why? Because the x coordinate of point C is the same as point B. So now let us define a point E with coordinates 1, 1, 3. So now we have our points D and E. So we're almost done. The only thing that we need to do is to draw lines so that this becomes something like a pyramid. So let me use this tool, the polygon tool, and let me draw the first polygon. So this is the first one. Let me move so you can see what I'm doing. Now we need another polygon to go from here to here. This is going to be like the back piece. And now we need another one which is going to go from D to E to A And the last one is going to be like the left wall, so to speak. So that's it. So that's the shape of the joint density function. Remember that the triangle in 2D is the base. The triangle is supposed to be in the xy plane, and all the points in that triangle are going to be mapped somewhere in this region, somewhere inside this pyramid. So if you want, you may try to integrate this function over y1 and over y2, and the integral, of course, must be 1. So the area inside this figure must equal 1. If it's not 1, then this is not a density function. So that's it for how to draw this density. We will see how to compute probabilities in the next video. Thank you, guys.